Welcome to another episode from the Veterinary Medicine Digest. Today, we're delving into a fascinating study on surgical knots, which are absolutely crucial in large animal surgery, especially for procedures like castrations. Preventing postoperative bleeding is paramount, and a secure ligature using strong suture material is often the answer. However, tying secure knots in deep surgical cavities or during laparoscopic procedures can be incredibly challenging. Traditional square and surgeon's knots often require precise, individual tightening of each throw, which is tough to achieve in confined spaces, potentially leading to insecure knots. This inherent difficulty highlighted a significant need for a more reliable, self-locking knot that could be easily slid into place and remain secure.
Indeed, and that's precisely where the double forwarder knot comes into play, building on the concept of the original forwarder knot, which provides a secure start for continuous suture lines, but can't form a full encircling ligature. This new double forwarder knot was designed to allow both ends of the suture to be individually tightened and locked. The primary goal of this laboratory study was to thoroughly evaluate the strength, specifically the knot holding capacity, and the physical size and weight of this novel double forwarder knot. The researchers then compared these characteristics to the more established surgeons and square knots, using common suture types. Their hypothesis was quite clear. They expected the new double forwarder knot to demonstrate increased knot holding capacity and, due to its design, also predicted it would be larger and heavier.
The results of this rigorous study were quite insightful, especially regarding knot holding capacity. For 2 USP polyglactin 910 suture, the double forwarder knots consistently exhibited a higher knot holding capacity than both square and surgeons' knots across all numbers of throws tested. With 3 USP polyglactin 910, the double forwarder knots also showed significantly higher knot holding capacity compared to all square knots. Interestingly, when comparing the double forwarder knot to surgeon's knots in 3 USP polyglactin 910, the double forwarder knot maintained a higher knot holding capacity with fewer throws. However, once surgeon's knots reached 6 to 8 throws, their holding capacity became comparable to the double forwarder. A notable finding was that none of the double forwarder knots failed due to unraveling, a common issue observed in some square and surgeon's knots with fewer than 6 throws. This suggests the double forwarder's unique self-locking design is very effective.
That's a key takeaway, as the self-locking characteristic of the double forwarder knot prevents unraveling, contributing to its superior strength. The study also confirmed the hypothesis regarding size and weight. Double forwarder knots were indeed significantly larger and heavier than both square and surgeon's knots when comparing the same number of throws. This larger knot size could potentially lead to increased tissue reaction in a clinical setting. However, it's important to consider that the double forwarder knot achieves its maximum knot holding capacity with fewer throws than square and surgeon's knots, which might help mitigate some of those size concerns. Furthermore, a significant advantage of the double forwarder knot as a self-locking design is its ability to be tied closer to the surgeon and then slid into place within a deep cavity. This feature could be particularly useful in challenging surgical environments, such as during laparoscopy, where precise, individual tightening of throws, as required by square and surgeon's knots, is often difficult.
So, in essence, the double forwarder knot offers a promising alternative for creating secure ligatures, especially in hard-to-reach areas where traditional knots are challenging to tie effectively. Its biomechanical properties demonstrate a clear advantage in knot holding capacity over square knots and surgeon's knots with fewer than 6 throws. While its larger size and weight remain a consideration, the fact that it achieves maximum security with fewer throws offers a potential benefit. It's important to remember that this was an in vitro study conducted under dry conditions, which is a limitation, as biological substances and fluid media in a living body can influence knot strength and behavior. Therefore, further investigations, both in vitro under simulated biological conditions and eventually in vivo, are certainly warranted to fully understand its performance and any potential tissue reactions. This research provides a solid foundation, much like laying a strong foundation for sturdy building, highlighting a new knot that can bear more weight or force with fewer initial steps, which is a significant advancement for veterinary surgeons.
Thank you for listening to the Veterinary Medicine Digest. The title for the referenced paper is in the video description. Remember to test your knowledge by answering the questions below, and, as always, keep those minds inspired, hearts light, and tails wagging.